Hello everyone, my name is V and I am here to taking on the challenge of 100 days reading books. And the second book I am starting with the second day is Defining and Discussing Climate Change. As you can see on the left hand page, we have at least around 7 contents of today's, and we're gonna take a closer look at climate change, about the discussion, the definitions, causes and effects, and the sustainable solutions in order to combat climate change as effectively as possible. Alright, so let's jump into it. Defining and Discussing Climate Change, Kirsty Mihaly, Shaping the Debate. Chapter 1: Changes Around the Globe, Flooded Cities, Deadly Heat Waves, Roaring Forest Fires, Polar Bears Stranded by Melted Ice, Droughts, Summer Flowers Blooming in Water. What on earth is going on? Earth is warming. A 2017 United States government report concluded that from 1901 to 2016, the average global temperature increased by about 1.8 degrees Fahrenheit or 1 degree Celsius. So as you can see, the little pictures demonstrating the consequences of climate change. For example, climate change melts the ice caps in Antarctic and the natural habitat of the bears are shrinking dramatically. Or climate change can indirectly lead to more severe and more prolonged droughts and floods or even fires, something like that. So average global temperatures aren't rising at the same time or at the same rate everywhere on Earth, but scientists have tracked temperatures on land and see to calculate the worldwide average temperature increase. The measurements show Earth is getting hotter overall. This warming causes change in the world's climate. For example, warmer air holds more water, allowing bigger storms to develop. Many areas are receiving more rain than normal. Floods have become more frequent and severe. So here's the map indicating, I guess, which country is more severely impacted by climate change. So you can actually take a closer look at that, but let's just move on. Global warming or climate change. Sometimes it is really confusing and frustrating to differentiate between these two concepts. So let's see the description. Global warming is one aspect of the broadened pattern of worldwide climate change. The concept of climate includes temperature, precipitation, wind, humidity, and storms. Scientists use both terms, global warming and climate change, to describe different aspects of Earth's changing conditions. I think that climate change is more prevalent compared to global warming. Global warming is kind of like similar to climate change, but climate change is more widely used among scientists to indicating the upward trend of the earth getting hotter, I guess. Some places are drier than usual. Hotter temperatures and longer summers dry soils and contribute to drier forests, which burn more easily. Since the 1980s, forest fires have grown larger and harder to control in the western United States and Canada. Shifting weather patterns have brought droughts to the Middle East, Asia, Africa, and elsewhere. The oceans are warming too. Warmer water expands, so oceans are rising. In addition, polar ice sheets and mountain glaciers are melting, further raising sea levels. The world's oceans have risen 4 to 8 inches, about 10 to 20 centimeters, in the past century. Many are alarmed by these changes. Biologists observe that plants, animals, and ecosystems are suffering. Farmers face rainfall and temperature changes that damage the crops. Coastal cities see higher floodwaters. Climate skeptics or climate change deniers dispute such concerns. They argue that changes in climate are a normal part of Earth's history. Some point to freezing winter temperatures and big blizzards and conclude that climate can be warming. This argument, however, ignores evidence of long-term temperature trends. Some skeptics, such as Scott Pruitt, former head of the U.S. Environmental Protection Agency, or EPA, suggest warmer weather could be good for people. Yet the U.S. government's fourth National Climate Assessment, released in November 2018, explains how global warming brings heat waves, air and water pollution, food shortages, increased disease, and other threats to human health. Meanwhile, U.S. policies responding to climate change have been inconsistent, changing as leadership shifts between the Republican and Democratic parties. Chapter 2: Carbon and Climate Change. At least 97% of scientists studying climate agree that human actions have caused rapid global warming. Since the Industrial Revolution began in the late 1700s, humans have added billions of tons of greenhouse gases to the air. These gases, primarily carbon dioxide, methane, and nitrous oxide, hold heat in Earth's atmosphere, warming the planet like a greenhouse warms plants. Most GHGs come from burning fossil fuels such as coal, oil, and natural gas to produce electricity and transport people and freight. Transportation and industry are major sources of carbon dioxide. Methane is generated by oil and gas production, by farm animals, and by trash rotting in landfills. Nitrous oxide comes mainly from agriculture and burning fossil fuels. For 4,000 years before the Industrial Revolution, carbon dioxide levels in the atmosphere were stable, ranging between 200 and 280 parts per million. In 2013, however, the carbon dioxide level reached 400 ppm for the first time ever recorded. It continues to increase. Ice cores. Paleoclimatologists study polar ice to learn about the long-ago atmosphere. The ice formed from snow falling over thousands of years. Deeper ice is colder. Scientists have drilled ice core samples more than 2.1 miles, 3.4 kilometers deep. Bubbles in the ice provide air samples some hundreds of thousands of years old. Scientists predict that as GHG concentrations rise, they will further disrupt the climate. Extreme weather events will continue. The oceans will become more acidic. Humans will face hunger and disease. Plants and animals will become extinct gradually. Ocean acidification. Since the Industrial Revolution, the oceans have absorbed hundreds of billions of tons of carbon dioxide. The gas dissolves, forming carbonic acid. This makes the water more acidic. Ocean acidification makes it difficult for marine animals to grow shells, and it kills coral reefs. Some dispute these predictions, arguing that changes in the climate are part of Earth's natural cycle of ice ages and warming. While it's true that natural events such as volcanic eruptions can affect climate, scientists have concluded that these don't explain the centuries-long changes. Other skeptics say human beings will adapt to new conditions. After all, scientists point out, however, that such adaptation takes many years and over a gradual period of time, and that humans are well adapted to the more stable climate that existed for most of human development. Chapter 3: Can climate change be ever stopped? Fighting climate change means slowing the increase of GHGs in the atmosphere by reducing new emissions and removing GHGs from the air. The most direct way to cut GHG emissions is to burn less fossil fuels. Renewable energy sources such as solar and wind power, which produce few or no GHGs, can replace fossil fuels. Electric cars create zero emissions, though producing the electricity they use may generate GHGs, but I think that the emission is minimal or incomparable to the amount of burning fossil fuels at least. Making homes, appliances, and factories more energy efficient also reduces emissions. The oil and gas industries oppose regulations aimed at cutting fossil fuel use. They say renewable energy sources are not enough. They're concerned that the proposed rules would reduce their profits. They also argue that cutting fossil fuel consumption puts workers, coal miners, oil rig operators, and others out of jobs, but many point out that renewable energy economy offers good jobs with a more sustainable future. Agriculture also produces GHGs. Commercial livestock operations that raise meat, especially beef, are major methane sources. Some people advocate eating less beef to combat climate change. Some farmers are exploring ways to reduce emissions by changing what they feed cattle and by limiting chemical fertilizers, which produce carbon dioxide and nitrous oxide. Cutting food waste, sending less to dumps, will save energy used in food production and also reduce methane emissions from decomposing trash. We still have a lot of pages to go, so I think I'm just gonna stop right now because I have to do some more exercises later on. So I think we're gonna continue this book tomorrow. Thank you.